So those who are online, please say hi in the chat window so that we can start the session. Hi Jay, Mary and Sonia. So let us wait for 1 minute for everyone to arrive. जैसे ही सभी आएंगे, we can start this session. Hi Shakti. So we'll wait for like 2 or 3 minutes before we start. अभी जो time हुआ, the time is 12:07. So we'll start by 12:10. 12:10 पे हम लोग start करेंगे. Hi Pratibha. Hi Neha. So I think we should start now. So basically in today's lecture we will be discussing about your pushdown automatas, and you will understand what is pushdown automata, why pushdown automata is more powerful. प्रतिभा, जो शेयर्ड आपके साथ क्वेश्चन है, आई हैव आल्सो शेयर्ड अ पीडीएफ फाइल विद यू ऑन द ग्रुप इटसेल्फ, एंड इन दैट पीडीएफ फाइल द क्वेश्चन दैट आई हैव गिवन यू दैट इज एन एग्जांपल. तो उस पीडीएफ फाइल में शेयर्ड पीडीएफ फाइल ऑफ आई थिंक केएलपी मिश्रा, तो वहाँ पर इफ यू कैन गो टू दैट फाइल एंड यू कैन फाइंड द टॉपिक विच इज रेगुलर एक्सप्रेशंस, यू विल फाइंड दैट सेम क्वेश्चन दैट आई हैव गिवन यू इन द प्रीवियस क्लास एज अ सॉल्यूशन. ओके, Jay will discuss the schedule maybe in the Telegram group, or after the class we'll discuss the schedule. Instead of discussing here, we can discuss the schedule over there. And we have Mary, so let us start now, I guess, right? So we can start maybe. If you guys are ready, we can start. So the time here is 12:09. So 12:09 हुए हैं, so maybe we can start. Okay. So in this session we will be discussing about what is a pushdown automata and why pushdown automatas are required. I already told you that we have something called as a finite automata. So if I say finite automatas which are without outputs, so these are 3 finite automatas. The first one is deterministic finite automata, the second one is non-deterministic finite automata, and third one is epsilon non-deterministic finite automatas. So we discussed about these 3 types of finite automata, which is DFA, NFA and epsilon NFA. Now I told you that we can convert every NFA to every epsilon NFA to an NFA. हम लोग जितने भी epsilon NFA हैं उन सबको NFA में convert कर सकते हैं, and we can convert every NFA to DFA. So how can we convert? Because there exists an algorithm. Using that algorithm I can convert this NFA to DFA. I can convert epsilon NFA to NFA. It means even if you are having a DFA, even if you are having a NFA, even if you are having epsilon NFA, all these 3 concepts are basically equivalent in power. You cannot say that NFA is more powerful than DFA. You cannot say epsilon NFA is more powerful than DFA, right? So because there exists an algorithm which is a polynomial time conversion algorithm, and using this polynomial time conversion algorithm we can convert an epsilon NFA to NFA and NFA to DFA. So I can say the power of a DFA is equivalent to the power of an NFA is equivalent to the power of an epsilon NFA. And what do I mean to say by power? Power means, is there any problem that you can solve which is extra, and for that problem DFA does not exist? Okay, I mean, is there any question or any kind of language for which you can create an epsilon NFA but you cannot create a DFA? If that language itself is a problem, right? So when we say a language means it is certain characteristics of a problem, that is a problem, and we try to create a NFA or a DFA to understand, to solve that problem, right? You can say it this way. Now this, for every problem, if there exists an epsilon NFA, there also exists a DFA. So these three are basically equivalent in power, correct? Now we know that there are some language that exists, for those languages you cannot create a DFA. जैसे कि if I say we have a language which is a raised to power n such that n is greater than or equal to 1. Now for this language we have a DFA, we also have an NFA, and we also have an epsilon NFA. For this language DFA, NFA and epsilon NFA, all these three things exist. But for this language, which is a raised to power n, b raised to power n such that n is greater than or equal to 1, you cannot create a DFA, you cannot create an NFA, as well as you cannot create an epsilon NFA. So basically you can say the finite automata does not exist for this language. इस language के लिए आप finite automata नहीं बना सकते. If I take one more example, let us suppose if you have a language like a raised to power n, b raised to power m such that n comma m is greater than or equal to 1. For this language, the finite automata exist. When I say finite automata exist, it means DFA, NFA and epsilon NFA, all these three things exist. But if I say the language is a raised to power n, b raised to power 2n, or b raised to power 2n such that n is greater than or equal to 1, for this the finite automata does not exist. Again, if you have a language which is a raised to power n, b raised to power n, c raised to power n such that n is greater than or equal to 1, for this a finite automata does not exist. यानी कि to solve these kind of problems, the finite automata does not exist. Now there are two major concepts here. Okay, if I say given an instance of a problem, you can solve it, there exists a finite automata. Okay, so let me write it out. Given an instance, the finite automata may exist, right? Or it will exist, I can say. Instead of may, I'll say it will exist. Now what do I mean to say by this is, if I say the language is a raised to power n, b raised to power n, c raised to power n such that n is greater than or equal to 1. Now for this entire problem, a generalized finite automata does not exist. But if I take one instance of this, what is the instance? The instance is a, b, b, and c, c. If we just ask whether this instance or this string is existing in this given language, so for specifically for this string I can create a finite automata, and that finite automata will exist. तो सिर्फ इस problem के लिए मैं एक finite automata बना सकता हूँ, and that will exist, correct? But so as I said, this is an instance of a problem. But if I take the entire problem, now for this entire problem the finite automata does not exist. Okay, so given an instance it exists, but otherwise it does not exist, right? So given instance if it exists, but again we want something, we want some kind of automatas or some kind of machine through which we can easily solve this kind of problem also. We want to solve this problem. Now for this given problem, the finite automata does not exist, but a pushdown automata exists. इस problem के लिए we do not have a finite automata, but we have a pushdown automata. And if I take one more examples here, if I take a problem, language is WR such that W belongs to A, B plus. For this problem, the finite automata does not exist, but pushdown automata exist. So what is the problem? Problem is a string and its reverse. So if I say W is A double B, then WR will become B double B A. So that means the string WR becomes A double B B B A. So this is a string. Now for this string you have a pushdown automata, but you cannot create a finite automata. Now let me give you a very interesting example. Let us suppose the language is WX WR such that W comma X belongs to A comma B plus. Okay, and we have a language which is WC WR such that W belongs to A comma B plus, and C here is an alphabet. Now these two examples are very interesting. Why these examples are very interesting? Because for this example you can create a finite automata, but for this example you cannot create a finite automata. So look at it carefully. Now these two examples are very important. Look at it carefully and tell me, can you write in the chat window? Any one of you can write in the chat window why for this example we have a finite automata, but for this example we do not have a finite automata. Can any one of you write the reason in the chat window for this? क्या आप में से कोई इसका reason दे सकता है कि if I say this is a language L1 and if I say this is a language L2, for language L1 we have a finite automata, but for language L2 we do not have a finite automata. L1 के लिए finite automata exist करता है, but L2 के लिए finite automata exist नहीं करता. Think about it. Can you write the reason for this in the chat window? So let me give you the reason. If you cannot find the reason, let me give you the reason. But still, I'm giving you time. Okay, let me do one thing. Let me give you more time so that you can write your reason in the chat window. Why for L1 there exists a finite automata, but L2 there does not exist a finite automata. Correct, Pratibha, you are right. So basically, when we say we have W, if I take this language L1, so language L1 says we have WX WR such that W comma X belongs to A comma B plus. So this is your language, right? Now in this language, if you look at this W and WR, that means this is the reverse. That means if W is AB, then WR will become BA. Okay, if W is AB, WR will become BA. And this X is any combination of A and B, correct? So let us suppose your X is ABA. So that means your entire string will become W, which is AB, X is ABA, and WR will become BA. Okay. Now given this string, the string is AB, AB, ABA. Given this string, and I do not give you these values, I do not know what are these values. Can you tell what is X, what is W, and what is WR? So you cannot tell. So why you cannot tell is you have a chance that you can extend X in such a way that this entire becomes X, and this becomes your W, and this becomes your WR. So basically this problem here, it can be easily converted to a problem, the strings which are starting and ending with the same symbol. So this is basically equivalent to saying strings starting and ending with same symbol, right? So this is equivalent to saying that strings which are starting and ending with the same symbol. I hope it is visible to all of you. But the second case here, it is not equivalent to that, because here we have length of C. C is just a character, so length of C is fixed, but here length of X I can expand in such a way that this will become the strings which are starting and ending with the same symbol. Correct? So for L1 language we have a finite automata, but for L2 language we do not have a finite automata. So we wanted a machine which can solve such kind of problems for which we cannot create a finite automata. जैसे कि for this we cannot create a finite automata, for this we cannot create a finite automata, now for this we cannot create a finite automata, right? So we needed one more machine which is more powerful than your finite automata. So I created a machine which is called as push down automata, or you can say PDA. So I can say the power of finite automata is less than the power of pushdown automata. That means there are more problems that you can solve with PDA but you cannot solve with finite automata. ऐसी बहुत सारी प्रॉब्लम्स एग्जिस्ट करती हैं जिसको आप पुशडाउन ऑटोमेटा से सॉल्व कर सकते हैं, बट यू कैनॉट सॉल्व दोज प्रॉब्लम्स यूजिंग योर फाइनाइट ऑटोमेटा. Hence pushdown automatas is more powerful as compared to finite automata. And the second important point here is, this is actually the first important point, and second important point is, because in case of finite automata you can say the power of a DFA is equivalent to the power of NFA, but this is not applicable in case of PDA. You can say the power of a non-deterministic pushdown automata is actually much higher as compared to the power of deterministic pushdown automata. So you can say NPDA is more powerful as compared to DPDA. जो NPDA है वो DPDA से ज़्यादा powerful है. Okay? Yes, Pratibha, please ask. NPDA is more powerful as compared to DPDA. Do you have any questions? Sure, Pratibha, I'll cover this last language also. These things I'm going to cover in this lecture, so you will understand it, don't worry. You will understand it in some time. Abhi you are not able to understand, but give it some time, give it like half an hour or 1 hour, then you will be able to understand it clearly. Okay? So let us give a formal definition of pushdown automata first, and then I'll show you with the help of an example. So as I said, in case of finite automata we have a tape, then we have a read write head. Basically it is a read head. It reads, so basically it is a finite control, and the finite control reads the symbol from the tape, and this finite control is having a finite memory. Right? So finite memory means it cannot store infinite amount of data, it can only store a finite amount of data. So you will see, I mean, what is the difference here. Then in case of push down automata, the difference is, instead of having a finite memory we are having a stack. So this is a tape, this is your finite control, and here we have a stack, and this stack is basically infinite memory. That means this stack can grow as much as you want in one direction. It can store infinite amount of data, but this finite automata cannot store infinite amount of data. This stack can store infinite amount of data. Now, because these stacks can store infinite memory, so you can easily get an idea that pushdown automata may be more powerful as compared to the finite automata, because there will exist some languages for which you can create a PDA but you cannot create a finite automata. And on this stack, the bottom of the stack is having a symbol which I am saying it is Z0. So it is not fixed that symbol is Z0, but in most of the books they are using Z0. That is why I'm also using this symbol Z0. Z0 it shows what is the bottom of the stack. So the definition of finite automata is Q summation delta Q0 and F. This is the definition of finite automata. In case of pushdown automata, the definition is like this: Q summation tau delta Q0 Z0 and F. So you can clearly see between these two definitions we got two more extra symbols. First symbol is tau and second symbol is your Z0. So if I write it here, तो डिफरेंस क्या है देखो, Q and Q both are same, summation and summation both are same, Q naught and Q naught this is also same, F as well as this F this is also same. So out of all of these tuples, 4 tuples are same, 4 tuples are exactly the same. So here Q is a set of non-empty set of states, summation is set of input alphabets, Q naught is the initial state, and F is the set of final states. Now if I say in case of finite automata, again we have these 3 types of finite automata, which is your non-deterministic finite automata, second is non-deterministic finite automata, and the third one is epsilon non-deterministic finite automata. Okay, so in case of DFA, this delta symbol, delta is Q cross summation takes us to Q states. In case of NFA, it says delta is Q cross summation takes us to 2 raised to power Q states. In case of epsilon NFA, the delta is Q cross summation takes us to, sorry, Q cross summation union epsilon, because here you can also have an epsilon symbol, takes us to 2 raised to power Q states, right? But here this is a difference. Here this tau represents stack alphabet. So stack alphabet means what are the alphabets that you can insert inside the stack. आप stack के अंदर क्या क्या alphabets को डाल सकते हो, क्या क्या alphabets को insert कर सकते हो, that will be your tau. And here Z0 represents the bottom of stack, and it is also a stack alphabet. It is also a stack alphabet. Just like here we take Q0. Q0 is one state out of this set of states. So here this Z0 is representing the bottom of the stack, and it is also called a stack alphabet. It is one of the stack alphabet. But here tau is the symbols that you can write inside the stack. So I think we have already defined it. So in this case, when we say pushdown automata, your delta function changes. So in case of pushdown automata, delta says what is your current state, what is your current state. So if you are at which of the following states, then what is your current input symbol, आपके पास input symbol क्या है, current input symbol, and then what is the alphabet which is present inside the stack. So top of the stack में कौन सा alphabet है. Now looking at these 3 things, you will tell what is your next state and what is the alphabet that you are going to insert inside the stack. So here you can see the next state is Q, 2 raised to power Q and 2 raised to power Q. So this is the case when we have deterministic pushdown automata. So you can write it down, deterministic pushdown automata. इतना क्लियर है आप सभी के साथ? Now if I say we have non-deterministic pushdown automata, in that case delta is Q cross summation cross tau takes us to 2 raised to power Q cross tau states. Okay, and we already know what is F and Q naught. So the basic difference and the biggest difference between all of them is this delta function. So delta function means it tells how you are going to make the transition. So you are going to make the transition on what basis. So in this case finite automata, we make the transition on the basis of what is your current state and what is your current alphabet. Here also, what is your current state, what is your current alphabet, what is your current state, what is your current alphabet, where epsilon is also included, right? So here we are making decision on the basis of 2 things only, your current state and current alphabet. But in the case of pushdown automata, we are making decision on the basis of 3 things. The first thing is current state, current alphabet, and what is the alphabet which is present on the top of the stack. तो stack में इस समय पर कौन सा alphabet present है. On the basis of these 3 symbols, I am going to decide what is the next state I am going to go and what will be the alphabet I am going to insert inside the stack. So this is again, as I said, we are making decision on 3 things. Here we are making decision on 2 things. So let me show you with the help of example, then you will be able to understand. Let me rub it up. I hope that you have written it down. So I think right, so you have already written done. So I'm going to rub it. So let me show you with the help of an example how can I make it, how can I do it, then you will be able to understand more clearly. Let us assume that we have languages a raised to power n, b raised to power n such that n is greater than or equal to 1. So for this language I want to create a pushdown automata. So first of all let us understand what are the strings that are present in this language. क्या क्या strings present होंगी? You can have a string which is AB, you can have a string which is AA double B, you can have a string which is AAA triple B, you can have a string which is 4A and 4B, and so on. This is the kind of strings that will be present in this given language. इस language में इस तरह के strings जो हैं वो present होंगी. Now out of all these strings, in all these strings, what I can do is I can take a stack and I will say, if I want to know whether the string is present in the language or not, let us suppose I'm taking the string AAA and triple B. If I want to know whether the string is present in the language or not, what I can do is, if I see the first A, I will insert this A inside the stack. Then if I see the second A, I will insert the A inside the stack. If I see the third A, I will insert this A inside the stack. Then as soon as I see a B, I will take this A out of the stack. As soon as I see another B, I will take this A out of the stack. As soon as I see another B, I will take this A out of the stack. Now after reading this entire string, because entire string is already finished, if your stack is empty, that means stack is only containing Z0, then we say that this string is present in the language. तो इसका मतलब है जो string है वो language के अंदर present है. But after reading this entire string, if there is some symbol which is left inside the stack, either symbol A is left or you have extra symbol B that you have to insert, then we can say that this string is not present in the language. तो उस केस में हम बोलेंगे जो string है वो language में present नहीं है. Is it clear? What is the functioning? So functioning is very easy. Whenever you have some symbols, so for example here we want to say whether AAA triple B is existing inside the language or not. So what I can do is I can take all these A's, I will insert all of these A's one by one inside the stack. Then I can take all these B's, and with every B I'm going to compare with A and I'm going to take it out. I can take another B, I'm going to compare with A, then I'm going to take it out. So this way we can perform all these operations. इतना clear है सबके साथ? I hope this much is clear. So how can you perform these operations? How will you do it? So this is your initial state. Let us assume it is Q0, and because they have written that length of the string is minimum 1, n is greater than or equal to 1. तो because आपकी length जो है string की वो 1 से ज़्यादा होगी, so what I can do here is that if your current state is Q0 and if I see a symbol A, beginning में you are going to get a symbol A. If I see a symbol A and in the beginning your stack will be empty, right? So here I'm going to write three things. So symbol A, Z0 slash A Z0. Okay, so what do I mean to say by this is, what is this format? So first of all I'm going to write next symbol, then what is the top of the stack symbol, then what is the symbol that you are going to insert in the stack. So these three things I'm going to write here. So what do I mean to say by this is, देखो, whenever you are going to see a symbol, you will take this top of the stack element out of the stack. आपको करना ये है, देखो, let us assume I have a stack here. So this is some element inside the stack and there is some new symbol is coming. So what I can do is I will take that symbol. What is the new symbol? I will take one symbol out of the stack, then I'm going to compare both of them. Accordingly, either I'm going to add both of them or I'm going to remove both of them. So basically this is the operation that we have to perform. So करना ये है, so what, whenever you are going to have a new symbol, you are going to compare this symbol with the symbol which is present on the top of the stack. So top of the stack में क्या symbol present है, उसके accordingly you have to perform this operation. Okay. So initially we get a symbol A and we check the top of the stack is containing Z0. In that case I'm going to insert the symbol inside the stack. So this is telling that insert them, so that means the stack will be having A and Z0. These two symbols will be there. Now we go to the state Q1. Now in the state Q1 again, if I see another A, अगर मेरे पास एक और A आता है and the top of stack will be containing A, so I have to check, yes, both these A's are there. So that means I have to insert this A also. Then I can say you get any number of A's and the top of the stack is also having a A, then insert both of them. So the first symbol is representing what is the symbol on the string. The second symbol is representing what is the symbol at the top of the stack. And the third, here it is representing that insert both of these A's inside the stack. Okay. So I'm doing this in the loop. That means if you get any number of A's here, so for first A, we have inserted first A inside the stack. For second A, the top of the stack is containing A and the symbol is A, so I'm going to insert it. For the third A, again the top of the stack is A and this symbol is A, so I'm going to insert it. For the fourth A, the top of the stack is having a and this is a, so I'm going to insert it. So basically any number of A's will be there, we are going to insert it. So that is why I kept this in the loop. तो इस तरह से मैंने इसको loop में रखा है. Now as soon as there is a B, जैसे कि after this, after inserting all of these four symbols, we get a B and the top of stack will be containing A. So as soon as we get a B and the symbol at the top of the stack is A, then I'm going to remove both of them. So this is representing epsilon. So that means take this A out of the stack, take this B and compare both of them, and then do not insert them back onto the stack. So this is representing this one, which is epsilon. Now then we go to the state Q2, then we can get any number of B's, top of the stack is containing a A, and then I'm going to remove both of them. And after the end, if the string is finished, for example, if this is your string is A, B, 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 B. So what happens is you inserted all these A inside the stack, then you compared all these B's, so all of them will cancel out each other. So after the end, when the string is finished, you will get epsilon symbol. When this entire string is finished, you will get an epsilon symbol. So if your next symbol is epsilon and the stack is containing Z0, because when you removed all these A's, the stack will only be containing Z0. So, and the symbol that is left is Z0. In that case, leave this Z0 as it is and you are going to accept them on the state Q3. तो उस केस में आप state Q3 में इसको accept कर लेंगे. Okay. So this is how I'm going to draw it. But again, I'll explain you the same thing again. But थोड़ा और ध्यान से समझते हैं. There are 2-3 things that you have to learn here. In case of finite automatas, if you are at a particular state, I have to give a transition for both A as well as I have to give a transition for B. And if we do not give a transition for A and B, that means both the symbols, then we say it is a non-deterministic finite automata. But it is not valid on pushdown automata. Pushdown automata में ऐसा नहीं है. In a pushdown automata, it will only be called as non-deterministic pushdown automata if you have two different transitions for the same symbol. अगर आपके पास pushdown automata में एक ही symbol के लिए दो अलग-अलग transitions हैं, तब हम उसको बोलेंगे नॉन डिटर्मिनिस्टिक. लेकिन अगर पुशडाउन ऑटोमेटा में आपने किसी सिंबल को मिस किया है, जैसे कि यहाँ पर मैंने ए को तो बनाया लेकिन बी के ट्रांजिशन को मिस किया है, तो उस केस में हम इसको नॉन डिटर्मिनिस्टिक नहीं कहेंगे. ओके. अगर क्यू नॉट स्टेट पर एक सिंबल बी आता है, तो अगर क्यू नॉट स्टेट पर सिंबल बी आएगा, दैट विल बी कॉल्ड एज ए डेड कॉन्फ़िगरेशन, क्योंकि हमने उसके लिए कुछ भी ट्रांजिशन नहीं दिया है. बट दैट डज नॉट मीन इट इज़ ए नॉन डिटर्मिनिस्टिक पुशडाउन ऑटोमेटा. सो देयर इज अ डिफरेंस बिटवीन बोथ ऑफ देम. Okay, so let us see how this entire thing will work. So we'll take 3 examples here. So first example is when the number of A's are more and number of B's are less. The second example is when number of A's and number of B's are equal. And the third example is when number of A's are less and number of B's are more. So we have taken 3 examples to explain this one. I think Pratibha, these examples will answer your question. It will answer all your queries. So in the first case, what will happen? This is your stack. Initially the stack is having Z0. So the first symbol is A. तो हमने सबसे पहले symbol A को read किया. So we read the symbol A. Okay. So understand, Pratibha ये समझ में आएगा आपको. Don't worry. I'll explain this again. Don't worry. So here you can see we have a symbol A here and the stack is having Z0. तो हमने क्या किया? So we check the first symbol is A and the stack is containing Z0. Then I'm going to insert them inside the stack. So inside stack will be containing A. Then the top of the stack is containing A and the next symbol is A. So it is saying the top of the next symbol is A, top of the stack is containing A. So this is next symbol, this is top of the stack. So next symbol is A, top of the stack is containing A. Then I'm going to insert this, both of them. That means I'm going to insert this A inside the stack. Okay. Then next symbol is again A, and the top of the stack is containing A. Next symbol is A, top of the stack is containing A. Again I'm going to insert this A inside the stack. Next symbol is A, top of the stack is again containing A, so I'm going to insert this A inside the stack. So basically ये सभी जो A हैं, because of this loop all these A's will be inserted. Then as soon as we get a B, जैसे ही आपके पास एक B आएगा तो top of the stack will be containing A. So as soon as we get a B, top of the stack is containing A, then I'm going to remove them. So that means I'm going to remove this A. Then as soon as you get another B and top of the stack is containing, as soon as you get another B, top of the stack is containing A, so I'm going to remove this one also. Then as soon as you get another B and the top of the stack is containing A, so I'm going to remove this one also. So after you read the entire string, you will get epsilon. क्या मिलेगा आपको पूरी string को read करने के बाद? You will get an epsilon. So once you get an epsilon and top of the stack is containing A, so that means we need a transition which is epsilon comma A, correct? So you can see there is no transition here which is saying epsilon comma A. So we have B comma A is there, we have epsilon comma Z is there, but there is no transition which is saying epsilon comma A. It means the top of the stack is containing A and the next symbol is epsilon. Because here you can see the top stack is containing A, the next symbol is epsilon. So basically we do not have any transitions here. So that means this will lead to a dead configuration. And this will be dead. It will say that this string does not exist in the language. जो string है language के अंदर exist नहीं करती. But if you look at the second case, in the second case what will happen, that if you get a A, you will insert all these A's inside the stack. Then as soon as you start getting a B, you will remove all these A's out of the stack, because number of A and number of B are equal. Then after the end of the string, the stack will be empty. So after the end of the string, we get epsilon and the stack is having Z naught. So for this we have a transition which is epsilon comma Z naught slash Z naught. That means in the stack leave Z naught and go to the final state. तो उस केस में आप final state पर जा सकते हैं. So you can see this string will be accepted. But if you see the third case, what will happen in the third case? In the beginning, I'm going to insert all these A's, right? So all these A's will be inserted using this loop. And as soon as I get a B, the top of the stack is containing A, then I'm going to remove them. Again, repeatedly do the same. Second B, remove it. Third B, remove it, right? So after removing them, what will happen? The next symbol is B and the top of the stack is having Z naught. So that means we get as B comma Z naught here. So you can see, do we have a transition here which says B comma Z naught? तो B comma Z naught के लिए यहाँ पर आपके पास कोई भी transition नहीं है. We do not really have a transition for B comma Z naught. So that means this string here this will lead to a dead configuration, because for this we have not given a transition. So that means it is dead, or you can say a non-final state, and so on. Okay, so you can see the first case also we will not reach a final state. Why? Because we get a transition which is epsilon comma A, and epsilon comma A we do not have a transition here. In the last case we get a transition which is B comma Z naught, and B comma Z naught is not present here. So both first and the last case they will not be accepted here. Only the second cases will be accepted, where number of A's is equal to the number of B's. इतना clear हो आप सभी को? Is this much clear to all of you? Any doubts so far? Good, if this much is clear. Now your second question was, you could not understand the difference between NPDA and DPDA. So देखो, basically what happens is, in case of DFA, we say it is a non-deterministic finite automata when two cases arise. The first case is for a certain symbol you have not given a transition, and the second case is when you have more than one transition for one symbol. तो DFA जो है, हम उसको दो केसेस में बोलते हैं कि DFA हमारा एक डिटर्मिनिस्टिक फाइनाइट ऑटोमेटा नहीं है. पहला केस ये है कि अगर आपके पास किसी सिंबल के लिए ट्रांजिशन गिवन नहीं है, अगर आपके पास लैंग्वेज में दो सिंबल है तो हर एक स्टेट में हमें दोनों सिंबल की ट्रांजिशन देना पड़ेगा. तो किसी सिंबल में ट्रांजिशन के लिए ट्रांजिशन नहीं है. और सेकंड केस ये है कि आपके पास किसी सिंबल के लिए एक ही स्टेट पर दो अलग अलग ट्रांजिशंस हैं, तो दोनों केस में बोलते हैं कि इट इज नॉट अ DFA, इट इज अ NFA. बट इन केस ऑफ पुश डाउन ऑटोमेटा द फर्स्ट केस डज नॉट होल्ड, right? So even if the first case is not holding, still we'll say it is a deterministic push down automata. If the second case holds, that means for one symbol we have more than one transitions, then we say it is a non-deterministic push down automata. Why? The reason is because we do not really care about the first case for this. You'll get to understand by this with the help of more examples. You'll understand it, but right now just understand that only the second case hold here. That means if for a state we have more than one transition for the same symbol, then we say it is a non-deterministic push down automata, otherwise we say it is a deterministic. So अभी सिर्फ इतना समझो, with the help of more examples you will be able to understand it why we do it this way. Okay. Yes, we have a minimum PDA also for a given PDA. तो हमारे पास minimum PDA हो सकता है. There exists an algorithm to minimize the push down automata also, but the problem is that is not required for our syllabus. It is very very complicated, and again it is not required for our examination purpose. So in our examination they only want to ask whether for this language PDA exists or not. They will not ask you to minimize the PDA. They will not ask you anything else. They will just say कि इस लैंग्वेज के लिए पुश डाउन ऑटोमेटा एग्जिस्ट करता है या नहीं करता. अगर इस लैंग्वेज के लिए पुश डाउन ऑटोमेटा एग्जिस्ट नहीं करता, दैट मींस इट इज नॉट अ कॉन्टेक्स्चुअल लैंग्वेज. अगर करता है, दैट मींस इट इज अ कॉन्टेक्स्चुअल लैंग्वेज. ओके, सो यू अंडरस्टैंड. लेट मी टेक मोर एग्जांपल्स प्रतिभा, यू विल अंडरस्टैंड इट इजीली. So let us suppose that we have a language. The language is a raised to power n, b raised to power m, c raised to power n, such that n comma m is greater than or equal to 1. So for this language I'm going to create a push down automata, and the second language is a raised to power n, b raised to power n plus m, c raised to power m, such that n comma m is greater than or equal to 1. So let us create a push down automatas for these languages. So in the first language what they are trying to say is number of A is equal to the number of C's. We do not really care about the number of B's, but number of A should be greater than or equal to 1, number of B should be greater than or equal to 1, and number of C should be greater than or equal to 1. The only thing that the condition that they are saying is number of A and number of C should be equal. So that means the strings that will exist in this language, they will be A, double B, C can be there. We can also have A, B, C, C. We can also have triple A, B, 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 C, 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 and so on. So number of A should be equal to the number of C. Number of B are equal or not does not really matter, right? We can also have 3A, 3B, and 3C, but only A and C should be equal. Okay, this is the first case. Now in this case, how will you make the push down automata? What you can do is, the strategy is very simple. Whenever you are going to get a A, you are going to insert all these A's inside the stack. जब भी आपके पास A आएंगे, सभी को आप stack के अंदर insert करेंगे. Whenever you are get a B, you are not going to insert B inside the stack. B को आप stack में insert नहीं करेंगे. And whenever you are going to get a C, you are going to compare the number of C with A, और A को stack से बाहर निकालेंगे. So after this, if the string is finished and the stack is empty, then we can say the string exists in the language. Okay. Yes, that was a deterministic push down automata. So right now I'm just teaching deterministic PDA. I'm not teaching non-deterministic PDA. I'm taking just examples of deterministic push down automatas. So this is the first state, which is Q naught in the beginning. In the beginning, as soon as you get one A, the initially stack will be empty. So I'm going to insert this A inside the stack. I go to the state Q1. Then I can get any number of A's. The top of the stack will be containing A. I'm going to insert all of them inside the stack. Then as soon as you get one B, top of the stack will be containing A. I'm going to leave A as it is. I'm not going to insert it. I'll go to the state Q2. जितने भी B आएंगे, so any number of B's will be there. Stack will be containing A. I'm going to leave all these A's as it is. And as soon as we get a C, the top of the stack will be containing A. I'm going to remove these A's. I go to the state Q3. So any number of C's will be there. Top of the stack will be containing A. I'm going to remove all of them. and after this, as soon as the string is finished and the stack is empty, then we say the stack is empty and we say it is accepted. So this is how you can create a push down automata for this. Okay, you can note it down, by the way. I'll explain you how it is working. So first of all, let us draw them, and then you can note it साथ साथ. Okay, so if you take the second example here, what I'm trying to do is I will insert all these. So basically here what I can do is, this language can also be converted to one more form. इस language को आप एक और तरीके से convert कर सकते हो. That form is this way. So we can also say it a raised to power n, b raised to power n, b raised to power m, c raised to power m, such that n comma m is greater than or equal to 1, right? So why I can do it? So whenever we have 5 raised to power 10, it can be converted to 5 raised to power 3 multiplied by 5 raised to power 7. So in this way, whenever we have b raised to power n plus n, I can convert it to b raised to power n multiplied by b raised to power m. So this is our concatenation with b raised to power m, then this will be equal. Now what I can do in this case is, whenever I get a, I can insert all these a's inside the stack. जितने भी आपके पास a आएंगे सभी को stack में डालो. As soon as you get a b, you can remove these a's, and when the number of a's are finished and you still have b's, then you are going to insert these extra b onto the stack. And then when you get a c, you can remove these b out of the stack, and then the stack is empty, so I'm going to leave it as z0. So let me make a PDF for this, and then I'll explain how this is working. Okay, so initially you are at a state q0. अब आपके पास initially you can get a a, because minimum number of one a will be there. The stack will be empty. Insert this a inside the stack. You go to the state q1. You get any number of a's. Top of the stack will be containing a. Insert all of them inside the stack. As soon as you get a b, top of the stack is containing a, you are going to remove all of them. You go to the state q2. Then you can get any number of b. Top of the stack will be containing a. You can remove all of them. But after some point of time, you get a symbol b, but stack is empty. So if you have a b and your stack is empty, I can make an extra state. Let me just make an extra state for this, for simplicity purpose. So if I get a b, the stack is empty, and then I can insert this b inside the stack. So by the way, without this function I can also give one here. I'll explain you later on, but for simplicity purpose I'm making a different state. So we can have any number of b. The stack will be containing b. I can insert all of them. As soon as you get a c, you can see the top stack will be containing b. You can remove all of them. Then go to the state q4. You can get any number of c. Top of the stack will be containing b. You can remove all of them. And as soon as your top of stack, your string is finished and top of the stack is empty, that is z0, we go to the state q5 and we can accept it. So this way I can make a pushdown automata for this language. So एक बार देखो, just try and understand what I'm trying to do, then I'll explain. Just take some time. So just take some time and try and understand what is the difference between both of them. What is the difference between the first one and second one is the difference between. Just try and understand the difference between both of them. Okay. Try to figure it out. मतलब take an example of a string and try to see how these both of them are working. ये दोनों कैसे काम कर रहे हैं. Take an example of a string and then you will understand कि कैसे काम कर रहे हैं. So let me explain the first one. Let us assume that we have the following string which is in the format triple A, double B, or 4 times B and triple C. So this is 3A, 4B and 3C. And we want to see whether the string is accepted here or not. So by the way, you can really look it up and you can say yes, the string is existing. But again, how will this string will be accepted here? So initially the stack is empty, that means stack is containing Z0. So the first symbol is A and the stack is containing Z0. That means you can insert this A and Z0 inside the stack. So stack will be having A Z0. Okay. Then the next symbol is A and the top of stack is containing A. The next symbol is A, top of the stack is containing A. So you are going to insert both of them again inside the stack, so you can have again double A. Again the next symbol is A and the top of stack is containing A. So आपके पास next symbol फिर से A है, top of the stack आपके पास A है, so you can insert them inside the stack. Correct? Next symbol is B and top stack is containing A. So we have next symbol is B and the top of the stack is containing A. So what I'm going to do is, I'm not going to insert this B inside the stack, I'm going to leave this A as it is. मैं इस A को ऐसा कैसा छोड़ दूंगा. Again the next symbol is B and top of the stack is containing A. I can leave this A as it is. So if we get one more B, leave this A as it is. One more B, leave this A as it is. One more B, leave this A as it is. This is what this loop is saying. And then as soon as you get a C and the top of the stack is containing A. So next symbol is C, top of the stack is containing A. So I'm going to remove this A from the stack. So that means I'm going to remove this A also. Again the next symbol is C, the top of the stack is containing A on the loop repeatedly. So whenever you get a C, remove this A. Whenever you get a C, remove this A. This is what this loop is saying. And as soon as this entire string is finished, जब पूरी string finish हो जाएंगे, then you will get an epsilon. In that case you will get an epsilon and the stack is having Z0. So you are going to leave this Z0 as it is and you are going to go to the final state. So that means this string will be accepted. जो string है आपकी ये accept हो जाएगी. Okay. Now in the second case what I'm trying to do is, I'll just take an example of a string. So if you have a string which is A, B, 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 so B and we have C, 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 C. So that means here you can see number of A's are 3, number of B's are 7 and number of C's are 4. So here what they are trying to say is number of B should be equal to number of A plus number of C. So what I'm trying to do here in this entire example is, initially your stack is empty, you will get a A. So you can insert all these A's inside the stack. So you can insert all these A's inside the stack. Now as soon as you get a B, you will remove this A. You get another B, remove this A. You get another B, remove this A. तो यहाँ पर हमने क्या किया? So यहाँ पर आपके पास whenever you are getting a B, you are going to remove A. Now as soon as you get one more B and your stack is having Z0, so this is saying when you get a one more B and stack is having Z0, in that case you are going to insert this B inside the stack. And again this loop is saying whenever you get one more B, insert them, one more B, insert them, one more B, insert them. So I'm going to insert all these B's because of this loop. इस loop की वजह से I'm going to insert all these B's inside the stack. And then as soon as you get a C, top of the stack will be containing B. I'm going to remove this B from the stack. So I'm going to remove it. One more C, remove it. One more C, remove it. One more C, remove it. So after comparing with the number of C's, your stack will become empty. That means stack will only be having Z0 and this string is also finished. So that means if you get epsilon comma Z0, then you can say it is Z0 and you are going to accept it by saying yes, the string belongs to the language. इसका मतलब है जो string है वो language के अंदर belong करती है. इतना clear आप सभी को? Any doubt so far? Good. I hope that you understood this part. So it was easy, right? It was not at all difficult. अगर आपने finite automata अच्छे से किया है, if you have good practice for finite automata, then you can easily do it and you will be able to understand it. Now let me give you one more example here, one more example of a language. So we have the language is a raised to power n, b raised to power 2n such that n is greater than or equal to 1. So what they are trying to say is whenever you get a, there should be two b's. So the strings that will be present here is a, bb, double a, 4 times B, triple A 6 times B, and so on. Okay, so this is your language, and for this language you have to make a push down automata. इस language के लिए आप push down automata बना सकते हैं. Now do one thing, take your time and try to understand how can you make it. So I'm giving you like 2 minutes, 2 to 3 minutes. Let's try to figure it out. तब तक मैं वापस आता हूँ, just be back in a minute. तब तक आप try करो कि इसको कैसे बना सकते हैं. I'm not turning off the live streaming, we'll be live here, but I'll just come back in a minute. तब तक just try and see how can you make a PDF of this. Yes. So Pratibha, have you already seen these lectures from the classes? I mean the recorded videos. Have you seen all these lectures before? Okay, so you are studying the subject for the very first time, and if you are studying it very first time and you are giving this kind of answer, that means it's brilliant, you know. People cannot figure it out. How can you do it? Even after studying the subject 2 or 3 times, they cannot answer easily. So let us explain. So there are 2 ways how can you do it. So we can have case number 1, I can say, and we can have case number 2. So, or you can say way, I can say, instead of case, I can say there are 2 ways of making this problem. So the first way is whenever you get a, you can insert 2a, and whenever you get a b, you can remove them. And the second way is whenever you get a b, do not remove for 1b. When you get 2 b's, then only you can remove 1a. Okay. Thank you, Pratibha. But again, this is brilliant. I mean, you are very smart and intelligent. So look at this one. So first way is, so insert 2 a's instead of 1. Insert 2 a's instead of 1. So you have an initial state which is q0. But as soon as you get a, initially the stack will be empty. So we are going to insert 2a instead of 1. You go to the state q1. Then whenever you get a, the top of the stack will be containing a, and you are going to insert all of them. Right? So that means instead of inserting 1a, I am inserting 2 a's. And then whenever you get a b, your stack will be containing a, then you are going to remove them. Then you go to the state q2. You can get any number of b, your stack will be containing a, you can remove them. And after this, if the stack is empty, you are going to leave it empty and you are going to accept it to the state q3. So this is the first case. I mean, in this case, whenever you get a, you are going to insert 2a, and whenever you get a b, you can just remove a, right? And then the second case is the case number 2. Whenever you get a b, do not remove a. When you get first b, remove a when you get second b. So that means initially at the state q0, you get a, insert these a inside the stack. You go to the state q1. You can get n number of a's, insert all of them inside the stack. As soon as you get a b, the stack will be containing a. do not do anything. The first B आने पर आप कुछ नहीं करेंगे, are not going to do anything on the first B. Then you are going to the state Q2. As soon as you get the second B, then you are going to remove it. So you go to the state Q3. Then on the third B, because I'm going to put this in a loop, on the third B, do not do anything. But on the fourth B you are going to remove. On the fifth you are not doing anything. On the sixth you are going to remove. After this, if the stack is empty, you are going to leave it empty and you are going to accept it. You are going to go to the state which is Q4. So basically these are two ways how can you solve the same problem. The first में हमने क्या किया? So let me take an example here. So let us suppose we have a string which is 3A or 2A and 4Bs. Okay. So in the first case, what we have done is whenever you get a A, you are going to insert 2A. Whenever you get another A, you are going to insert again 2A. And whenever you get a B, you are going to remove 1A. Second B, 1A. Third B, 1A. Fourth B, 1A. And then you can accept it. In the second case, what we have done is whenever you are getting a A, just insert 1A. Second A, 1A. Then when you get a B, when you get the first B, do not do anything. But when you get the second B, remove 1A. Again, when you get a third B, do not do anything. When you get the fourth B, remove 1A. So that means after reading this entire string, we get epsilon, and then we are going to accept it. So these are two good ways to draw the same, to solve the same problem. Okay. I hope that you understood this one. Very easy, right? It's one of the easiest problem. Now let me give you a very interesting problem here. So I'll make a solution for this. The language is WCWR such that W belongs to A comma B plus and C is a single character. Okay. For this I'm going to create a pushdown automata. Now we have second language which is A raised power n, B raised power n, C raised power n such that n is greater than or equal to 1. Okay. Now this is your homework. Okay. And I'm going this on record that if you can make a working pushdown automata for this, then I will give you 1 lakh rupees as prize money. Okay. So this is a homework. So this is a giveaway. तो अगर आप इस सेकंड प्रॉब्लम के लिए यहाँ पर पुशडाउन ऑटोमेटा बना पाएंगे, then I will give you 1 lakh rupees. So not just me, the whole world is going to give you a lot of money. If for the second problem we can make a PDA. So basically for the second problem we cannot make a pushdown automata. Only for the first problem we will be able to make. So let us see the first problem here. So it is saying WCWR. That means if you have a string W which is A, B, B, A, then your WCWR will become A, B, B, A, C, A, B, B, A. Okay. So Pratibha, yes, you can try it. When you get time, just try it. So here when you have a C, C is basically acting as a partition. It is saying that whenever you get a C, then the reverse of the string begins. Let us suppose if we have the W, the string W is A, B, B, A, B, B and single A or maybe one more B. So WCWR will become A, double B, A, double B, A, B, C, B, A, double B, A, double B, A. So this is how you get WCWR. Okay. So how can you do it? So whenever you get a string and its reverse, so if you have this string and here from this point its reverse is there, so you can see these things are matching. Okay, so what you can do is whenever you get the string, insert all these characters inside the stack, and whenever there's a C, so after this C I will know that yes, the reverse of the string is coming. So the reverse of the string is coming, then I can match these characters and I can remove them from the stack. It's very, very simple. So if you have an initial state which is Q0, now in the beginning See, because they have written a plus b plus, so this plus is important, because अगर यहाँ पर plus नहीं होता, instead of plus they have written star, then the PDA will be different. But because they have written plus, so PDA is again different. Plus means you should have minimum length 1. The length of the string of W, the length of the W is minimum 1. If we have star, that means the length of W is going to be minimum of 0. So in case of 0, we'll be having different PDA. In case of 1, the length 1, we are going to have a different PDA. So initially what we are saying is, initially if you get a symbol A and the top of the stack is Z0, insert this as it is, or if you get a symbol B, top of the stack is Z0, insert this as it is. So basically what we're trying to say is, initially you can get A or B, any symbol whatsoever, so you get any symbol, just insert all of them blindly on the stack. So जो symbol आएगा सबको हम blindly insert करेंगे. So we go to the state Q1. Now in this state Q1, I'm going to insert all these symbols. If your top stack is containing a A, insert it inside the stack. If your top of the stack is containing a B, insert this into the stack. If your top of the stack is containing A, insert this inside the stack. If your top of the stack is containing B, insert it inside the stack. So there are 4 cases. So whatever symbols you are going to get in the beginning, you can insert all of them blindly. Just insert all these symbols inside the stack. But as soon as you get a C, your top of the stack might be containing a A, leave as it is, or top of the stack might be containing a B, leave as it is. So as soon as you get a C, whatever the element is in the top of the stack, leave that element as it is, and then you can start removing the elements. You go to the state Q2 and now you can start removing the elements. So जितने भी elements है सबको आप remove करना start कर सकते हो. So what you can do again, so I can make one more extra state, but for simplicity let me just remove from here only. So after this, these symbols will be matching. So B will be matched with A will be matched with A, B will be matched with B, and so on. So whenever you get a A, remove it. Whenever you get a B, remove it. That's it. And as soon as the stack is empty, leave it as empty, and you can accept it in state Q3. So this is how you can make a PDF for this. इतना clear आप सभी को how this is working? So let me explain again. Let us suppose W is A, B, A, A. Okay, this is your W. Then your WR will become double A, B, A. So your string WC, WR will become A, B, double A, C, A, B, A. So what I'm trying to do here is, initially if the stack is empty, that is stack is having Z0. So the first symbol is A. So first symbol is A, stack is empty, so just insert this symbol. Next symbol is B and stack is containing A in the top, right? So next symbol is B, stack is containing A, so just insert B inside the stack. Next symbol is A, stack is containing B. So next symbol is A, stack is containing B, insert this inside the stack. Next symbol is A, stack is containing A. Next symbol is A, stack is containing A, just A, insert A inside the stack. And as soon as we have one C, the top of the stack might be containing A, top of the stack might be containing B. Anything can be there, right? Then I will just start moving them. I just start matching them, because this A will be matched with this A will be matched with this A, this B will be matched with this B. So they will always be in a matching. And then I'm going to start removing all of them. After I removed all of them, the string is finished, then I can accept it, right? That is called acceptance by empty stack. यानी कि जब stack आपका empty हो जाए, then you are going to accept. So this is acceptance by empty stack. कितना clear है सबको? Is it clear? Any doubts so far? Is there any doubts so far? Good. You guys are super smart, super intelligent. Good. So let us continue then. So I'll give you some of the examples, and for these examples you have to create pushdown automata for your practice, because I'm not covering all of them. I just covered 3-4 examples. I guess these many examples are enough. So let me give you some questions for practice purpose. Okay. So questions are like this. The language is a raised to power m plus n b raised to power n c raised to power m such that n comma m is greater than or equal to 1. Second language is we have a raised to power m, b raised to power n, c raised to power m plus n such that n comma m is greater than or equal to 1. The third language is a raised to power m, b raised to power n, c raised to power m, d raised to power n such that n comma m is greater than or equal to 1. Now for this language you just have to tell whether you can make a PDA or not. That's it. तो इसके लिए even if you are not able to make a PDA, think about it and tell me why you cannot make a PDA. So I'll tell you the answer later on. So during the breaks you can practice all these questions. If we have a raised to power m, b raised to power n, c raised to power n, d raised to power m such that n comma m is greater than or equal to 1. Then we have a language which is a language is a raised to power n, b raised to power n, c raised to power n, d raised to power n such that n comma m is greater than or equal to 1. Then we have, so n is greater than or equal to 1. So again for this language you have to tell whether you can make a PDA or not. इस language के लिए आपको सिर्फ ये बताना है कि आप इसके लिए PDA बना सकते हैं या नहीं. Next, a raised to power n, b raised to power 2n, c raised to power 3n such that n is greater than or equal to 1. Okay. Then we have a language which is, let me give more examples. Fine. So the language is a raised to power n, b raised to power 2 raised to power n such that n is greater than or equal to 1 and so on, right? So let us just take these examples, and for some of these examples you can make a push-down automata. For some of these examples you cannot make a push-down automata. So you have to tell कि किसमें इसके आप push-down automata नहीं बना सकते. If I take a language which is WR such that W belongs to a comma b plus, again for this example you can try and see whether you can make a PDA or not. इस एग्जाम्पल के लिए आप मुझे बताएंगे कि आप PDA बना सकते हैं या फिर नहीं बना सकते. So in this lecture we just covered the basics of push-down automata, that what exactly is a push-down automata, and we have seen few examples how can make a deterministic push-down automata. Okay, तो उसके हमने कुछ examples यहाँ पर लिए थे, and I've given you these examples. Now your job is to try and solve these examples during the break time. तो अभी जो हमारा ब्रेक है that will be from 1:30 PM से लेकर we have a break till 2 PM, right, approx. So we will continue the class at 2 PM. So during the break time you will try and make push-down automata for these languages. इन सभी languages के लिए आप push-down automata try करेंगे. And after the break I will teach you what is a non-deterministic push-down automata. और non-deterministic push-down automata बताने के बाद I will teach you how and why for some of these languages you cannot make a PDA. So I will take like examples of like 30 to 40 languages, and for all those languages I will tell you why you cannot make a PDA. But again, so just take a break right now and we will start the class again at 2 PM. Or meanwhile during the break just try and make push-down automata for some of these languages. So let me tell you, some of these languages you will not be able to create, but for some of them you will be able to create. Okay, so we'll meet at 2 PM और हम लोग 2 PM पर क्लास कंटिन्यू करेंगे दोबारा से. क्लियर? सो जल्दी से लाइक कर दीजिए सभी वीडियोस को. दोज फॉर वाचिंग द क्लास प्लीज़ लाइक द वीडियो, बिकॉज अगर नंबर ऑफ लाइक्स नहीं आएंगे सो क्लास को कोई बेनिफिट नहीं है. सो प्लीज़ लाइक द वीडियो. सिर्फ 3 लाइक्स आए हैं क्लास में, ओनली 3 लाइक्स. आई नीड 10 पीपल आर वॉचिंग, आई नीड 20 लाइक्स. गुड 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 गुड.